Hey guys, Abraxas here, and I'm going to be playing some Space Engine. Oh, wow, that's a weird song. Okay, well, anyways, yeah, I slept in last night. Kind of a long night. Thanksgiving was great. Went awesome. But, yeah, let's go ahead and get started. I will get back onto a kind of early morning schedule, possibly tonight. So any suggestions from this episode to tonight, possibly around 2 a.m., will make it into the next video. Because basically I'm going to record it the next time I'm awake, and that's a little bit loud on my end, so I'm turning that down. Okay, so let's go ahead and get started. Let's see, the first suggestion is from Derpsauce Gaming, and he wants me to visit a planet and its moon. It is a planemo with life. Oh, okay. Let's go ahead and check that out. I've actually been looking for one of these. I don't know what kind of life it's actually going to be. But let's go. Frozen gas giant with life. Saw the star motion blur on. Yeah, I have my settings changed up because I'm assuming the planet's loaded. I just can't see it. Yeah, I have some of my settings changed up because of the video yesterday. Let me turn off the star motion blur. I don't like that. There we go. Okay, so we can't see it, but there's a gas giant there with aerial life, which is super interesting. But it's also super cold, so that might just be a bug. But let's go ahead and turn up the ambient brightness, and we have a beautiful blue gas giant here. I don't see any moons orbiting around it. I see a big storm on it though, which is kind of interesting. It might possibly be warmer where that storm is. Cool. And I'm sure it... No, it doesn't actually have any, well, it has one moon, but not a lot of moons. It's actually, quite close to Barnard's Loop as well. There's Pleiades Nebula. So this has to be pretty close to our very own sun. In fact, I think it was Control H. Oh, is it Shift H? Ah, it's Shift H. There we go. There's our sun over there. And we're currently a distance of 23 light years from the sun, so very cool. And you can actually see the sun, even though our sun is actually a pretty dim star in comparison to some stars out there. We can see our sun from here. In fact, we just fly over. We were 23 kilometers out. Here's our sun. Okay, let's go back to that planet. Definitely can't see the planet from there, even with the ambient. Kind of a oval-shaped planet. It's not perfectly round, actually. I don't believe. That or my field of view is just tweaked. Very cool. Ice world itself is pretty dim and just as cold as, in fact, actually colder than that gas giant over there. So, very cool. There's a gas giant with life. I'm looking for like a Terra with life, like plant life or something, some type of, I don't know, life that does not go based on photosynthesis and all that kind of stuff. That would be awesome. If someone finds that, do let me know. I don't know if this is actually possible in this game, though. Anyways, let's go ahead and move on to the next suggestion, which once again is from Derpsauce Gaming. It says it's a ringed desert with life. He found it while looking for Mars-like planets. Okay, so let's go ahead and check it out. And this one looks like it's outside the Milky Way, and out in some possibly random galaxy. Are we in a random galaxy? No, we're in Triangulum. We're actually not too far out. Okay, so this is pretty cool. I see a hurricane. And it looks like we got that standard purple life, which is kind of weird because these like stripes that are going across the planet. I know both of those are life textures, I just don't know why they're striped like that. But as you can see, we have some nice polar ice caps. I wonder if they're actually elevated or if they're actually craters. Actually, it looks like it mostly maintains the same altitude. Might be going up a little bit in altitude. You can see that nice orange reflection from the star that's not quite appearing yet. And there it is. Very cool. Oh, and that looks really nice, the reflection on that ice there. Yeah, it's really nice, the detail layers they're using for the ice. Let's see, Very cool. That's where the spiky mountains actually do kind of fit in. When they're not very tall and they're just on the ice. Definitely got some active volcanoes going on. This planet doesn't have much of an atmosphere. Actually, it kind of does. It's 70% of the atmosphere of Earth. And it's comprised of CO2 and oxygen, so never mind, it actually does have a kind of thick atmosphere. From where I am, it's just not very visible. Let's go over to the daytime sky and see if it's any different. No, it's actually pretty close to the ground. That might just be because we're on the polar layer. Here, no, it's just a very thin atmosphere. You can see all the planets and stars just kind of around here. You can see the planets orbiting that star over there. And let's go ahead and check out these hills. You can see the aurora from here. And this cloud layer is super low to the ground. Looks like it has 2 cloud layers. It certainly does. And let's go check out what the life looks like. So we have the lighter purple texture over here. Let's check that out first. We got what looks like a bunch of treetops or something. Okay, sorry, I got a little bit sidetracked. Okay, so the darker texture actually is consisted of basically the same texture as the other one. Like you have over here, kind of that treetop-ish texture or something. Yeah, they got that kind of same thing going on here. So let's go ahead and back out of here. And let's move over to the darker side of the planet, which actually is just very densely packed of like a darker version of that kind of clover-ish texture thing. Nonetheless, very cool. Let's go ahead and fix our ambient lighting. I accidentally left that. Oh wow, that actually makes that look a lot nicer. And we have some nice kind of orange rings going on. So yeah, let's check out that snowfield real quick, just with the darker lighting, and that volcano is glowing much brighter. Okay, now we can kind of see more of the details of the snowfield. Very cool. Okay, so let's go and move on to the next suggestion. Okay, so I'm just reading off a comment from Neon Blue Bot. He wants to see the planets up close in space or in Universe Sandbox. Not too much. You want to see like the planets collide or fly off. I mean, if you want to see the planets up close, it is kind of a low-res texture, and yeah, there's not really a point in viewing up close. And a lot of my videos show what happens to the systems that it's in, not really the planets itself. So I just figured I'd mention that. Anyways, this next suggestion, which is this lovely blue cold desert with life, is from Infrared, and it looks absolutely amazing. Okay, so let's go ahead and check this world out. Okay, so let's check out this blue region first, since it looks very interesting and kind of different. So it looks like we have a nice orange cloud layer, and where is the parent star? Right over there. And then it's a white subgiant. Okay, so let's go ahead and zoom in here. Looks like we have some polar caps on these mountains here. Or not polar caps, but snow caps? No, it's not snow caps, it's actually the texture of the hills. It's the orange sedimentary rock texture, and looks like the purple life again is consisting of these clovers here. Well, that's an odd effect. Got like some scratch looking thing going on here. Haven't seen that before. Were these mountains just grinded out with a giant grinder or something? What's going on here? What's this? Oh, it's that root texture. Yeah, I'm a bit confused by this. Ooh, over there we have what I can only assume, yeah, is our main planet, which is a gas giant. We're actually orbiting around it. Look at this view. Just want to take a moment to, like, look at this. This is amazing. Just get my cursor out the screen. That is an amazing view right there. You, sir, I think just got thumbnail for this video. What happens if I decrease the field of view? There we go. Now I get the gas giant a little bit bigger. Let's get that loading circle off the screen. Just get out of here. Yeah, there we go. So that is a thumbnail for this video. That is awesome. Okay, so very cool. We have like the I assume that is like a top of rainforest, but it's just purple and it's kind of hard to tell. Plus, you just look at how bright these stars are. That's amazing. Got our aurora effect going on here. I do have the loading speed turned down, so things are taking a little bit longer to load. I can fix that in just a moment. Let's go ahead and go over to the less blue area of the planet. Okay, so let's touch down on this purple area. Kind of where this, where it looks like it's actually affected by water or something, or it's just patchy terrain. Okay, so we have our kind of whatever texture that is mixed in with that treetop texture and that texture. I don't know what these are. It's harder to tell when they're like purple and stuff, but sometimes you could tell that it's like the same textures used on the green worlds. Like this one, yeah, I see this one quite a bit. But very cool nonetheless. Let's check out its information. So it has a pressure of 0.05, so 5% of that of Earth. The atmosphere is very, very thin. Carbon dioxide, oxygen, and it has a diameter of 14,000 kilometers, which is not too much bigger than Earth, a little bit bigger. It has an ESI of 72%, which is actually pretty high for a desert world. A semi-major axis of, what is that? 2.2 million kilometers. Almost 2.3 mil. So not actually too far from its parent star, I don't think. Oh, no, wait, that's from its... Okay, yeah, that would be from its gas giant parent over there. Okay, never mind. I'm just dumb. And yeah, very cool. Okay, so... Infrared's telling me this is a white dwarf orbiting the largest central black hole in the universe. The black hole has an accretion disk of 6 light years across. So I think we could all guess what this is. I think I'm about to go visit IC 1101 and one of the white dwarfs that are orbiting around the black hole. Oh yeah, this is IC 1101. We just made it render in. So I have a video specifically on this. I'm not going to be able to link it here, but if you just go onto my channel and search for the video, just search IC 1101, I'm sure you'll find it. I have a video of me specifically pointing out that there's white dwarfs orbiting this thing. And if I can select the black hole here, which I have, there's actually one a little bit closer. If I go over to this one right here, we have this white dwarf. Whoops, I flew into it. I'm a little bit lost. One moment. I'm going to try to back out of this real quick. You can see there's one with an accretion disk right here. And right next to where the black hole is actually bending light. So, yeah. And if I hit play, they do spin fairly quickly in comparison to the black hole itself. So, yeah, this is IC 1101. Yeah, I've actually been here, and I've actually been to the white dwarfs. I actually pointed it out one time. Most central black holes actually do have white dwarfs around them. You just try to select the black hole, and then you just click on these little white dots, and they're typically black holes. There's a red dwarf right there. And yeah, there's actually a carbon star also orbiting IC 1101 right over here. Check that out. So yeah, I actually have quite a few videos on IC 1101. This is actually not the first time I've actually checked out the white dwarfs orbiting around it. So yeah, it's a really cool black hole for those who have not seen it, who are new to my channel. If you come over here to where it cuts off, basically from here to that black hole is a distance of, well, I'm actually still going a little bit. Yeah, it's about 1.5 light years across from here to the center. So if I come around here, it's the same deal. Basically, this black hole is 3 light years across, not actually 6 like he said. But, yeah, it's very awesome. And if you have the game, I do recommend checking out IC 1101, because this black hole is incredibly huge. In fact, the first time I seen it, it actually scared me when it popped in, because I'm used to flying like really, really close to the dot, and I flew like right here, I think, and it just popped in like really large on my 4K screen. I was like, oh shit. And pardon my French. But yeah. It's a really awesome black hole. And really cool galaxy, but obviously very custom made. So let's go ahead and move on to the next one, which is from This Is Not Interesting. He said, one cool fact. The fact won't let you look at randomly generated galaxy names. And the first 6 numbers of the planet is the galaxy's name in it. Okay. I actually knew that. Well, I kind of knew that. I didn't know like how far it actually went. But I realized that in previous ones, it's not actually the first 6 numbers. It's actually the okay, so let's just select your thing real quick. I'll open up this planet real quick. Okay, so let's go over there. Temperate desert. I don't even see it. Okay, whatever. It's a Planemo. Okay, so we have this temperate desert here with an ID of RS 0-0-0-461. Okay, let me close that. That's probably what's making that bug out. Yeah, that wasn't a Planemo. It was just bugging out because I have the chart still up. Okay, so we have this planet selected. It is 0-0-0-461. It's not actually the first 6 numbers like you're implying. It's the first 4 sections. So if I go ahead and select this galaxy, you'll see that that's the galaxy. So if I go very, very far off, away from the 0-0-0 galaxies, like really, really far off, let me make sure that I have auto increase the brightness of galaxies. I go to one very, very far away. Like, let me turn around 180 degrees and find one that's redshifted and go to that. No, this one's still 0-0-0. I believe there is a point where you'll actually find things that are not 0-0-0. But you have to go quite a ways. So let's just keep going for a while. I see a really dim red one there. No, I guess not. I know that's not correct, though. Yeah, there we go. There's one that's not. So this, for example, yeah, it's not the first 6 digits. That one, for example, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10. It's the first 4 sections. So I figured I'd point that out. And yeah, it's a completely different galaxy, but let's select a star, which also has the first 4 columns. And if we select like this black hole, yeah, you can see that it has the same first 4 columns, but a bunch of additional IDs after it. So it's just kind of a neat thing to point out. Okay, so the next suggestion, once again, is from This Is Not Interesting. He wants me to go back to IC 1101, ironically. So let's go ahead and head over there. I really hope that was misuse of the word ironic, so let's go ahead and check this out. Okay, so Control double tap G, and here we go, straight into the center of the... Here it comes, and there's the black hole. Got a neighbor's dog barking. Okay, so he's saying if I go to a star around this galaxy, I can find one that possibly has a planet orbiting around it. Yeah, it's not too difficult to actually do that, but here we go. Wherever this planet might be. There's a black hole. I think what he's trying to say is there might be a very, very close one, so let's go ahead and go into the black hole here. Just dive right on in. I don't know what that white dot is. Hey, white dwarf. Behind the black hole. It's just rendering weird. So, now we're basically in the black hole. Bring up our star search and just search 10 light years. And what he's saying is... he's saying anything with life that's 500 light years. To be honest, I don't think anything with life would actually survive 500 light years from this thing, but I could be wrong. Okay, so let's just search for a planet here. Let's not bother with life. Yeah, let's just search any object. So, Let's go ahead and go to the closest one, which is 0.5 light years. This one's 0.2 light years away. Oh wait, I might just be looking at stars though. There's stuff orbiting around it, so let's check out a moon on this gas giant right here. And time is moving. Let's pause that. And let's just land right here. Now that would be terrifying. Imagine just having that in your night sky. It's actually bending light from right here, so you can actually see like the distortion of the stars. You need to be able to accurately look at things past that black hole there. So here you go. This would probably be a bit terrifying. This is one of the closest planets to the black hole itself. See if we can bring up something maybe even closer. So this is the same star. Let's go to this one. And here we go. Just touch down on this little binary planet here. Okay. So yeah, we're not even near the other end of this accretion disk. So yeah, I don't think you would actually be able to survive this just because of the immense radiation that would probably be casted from this black hole. In fact, if anything, it could actually be shooting out gamma rays and have tons of gamma radiation. Basically, all these planets might just be molten. Or if they're even like in that vicinity, they might actually get shredded up by the accretion disk, who knows. But yeah, this black hole is incredibly huge. Whether it's like that in real life, we don't really know. But this is apparently the biggest galaxy that we know of. In fact, it's so large in our night sky, we thought it was like a nebula or something. So, yeah, very cool. And what's cool is you can actually see the lensing effect from pretty much all the way outside of this cluster. Alright, so let's go and move on to the next suggestion, which is from Nefdigitydog, or Nefdigitydog, and he is saying to visit to actually catalog things. So, this is apparently the furthest exoplanet that we know of. Are you the one who was suggesting all those record-breaking stars in the last episode? Okay, so let's go and check it out. Get that off the screen. Yellow dwarf, and this might be our furthest exoplanet that we know of. And it has a rotational period of 43 hours. So I don't think I'm going to be recording any real-time videos of this one, but I guess this might just be a gas. Yeah, it's a gas giant, scorched gas giant. Very cool, and it was discovered in 2006. I don't know if that would still hold the record. We might have found something even further than that. But yeah, very cool. And much like many different systems, this gas giant actually orbits very close to the parent star, which is actually pretty common. In fact, that is kind of one of our Planet 9 theories, is shouldn't we have had something between Mercury and the Sun? Possibly a gas giant, but yeah. Basically, it's missing, and we're wondering where it's at. We think that might just be Planet 9 that got ejected out from the Sun's orbit somehow. That's one of the many theories. But very cool. And the next one is the most massive exoplanet. And here we go. Cold gas giant. Okay, so it's pretty nice looking. What's the mass of this versus its brown dwarf star over there? So you got this brown dwarf, which might just be a red dwarf. Massive exoplanet. Is this like one of those planets that are like on a fine line of being like a brown dwarf or something? It was discovered in 2013. Direct imaging. It's very dim, and it's orbiting around what I can only assume is probably a red dwarf, because we don't really see brown dwarfs very well. It's a star that's basically achieving fusion, but over here is our cold gas giant, which is orbiting not too far away. But in the game, it actually generated some really nice, large, beautiful rings, which is very cool. Yeah, pretty awesome. Go ahead and check out the next suggestion, which is from Margaret Panichis. It brags on Universe Sandbox 2. If you want that spiral effect, place down a black hole and then put down a galaxy near the black hole and suck in the gas. Yeah, the thing is, that would require like a supermassive black hole, but on top of that, it would have to be even larger than a supermassive black hole, and it would have to be like basically on the size of a galaxy. That would be insane. I know I could use the particles from the galaxy, but the thing is, that would not make the accretion disk effect that I want, because the particles that are used in Universe Sandbox 2 for the galaxies, well, they don't actually block out the black hole at all, or refract around it. The black hole is actually visible through those particles. So, that wouldn't really work. And it's supposed to be kind of off-center from the sun, because the Pleiades Nebula looks a little bit off. There we go. That's a little bit more of the sun's neighborhood now. Okay, so let's go ahead and move on to the next suggestion, which is from Garishan. I don't know. It's his first suggestion, though. Welcome to the channel, and it's a Wolf-Rayet star in a random galaxy. Let's go ahead and check it out. I imagine it's going to be incredibly, incredibly bright, and possibly orbiting with a blue luminous supergiant. Or a blue luminous main sequence star. And here we go. Binary system. Look at that. Wolf-Rayet star and a blue main sequence star. What do you know? So, there is our blue main sequence star, and there's the Wolf-Rayet star. So, if I zoom out here, you can see it's, yeah, it totally changes, like, brightness whenever depending on what star is blocking what out. So, if I go over here, it gets dimmer. Then over here, it's brighter. Dimmer, brighter. So, yeah, kind of cool. And we actually have things orbiting around it, so let's go ahead and check one of these things out. Okay, so it's a hot desert, and I don't even see the stars. There they are. We must be quite far away for them to only be that bright. That strikes me as odd. How far is this actually orbiting from it? Semi major axis of 410 astronomical units. Okay, that sounds a little bit on par. Yeah, it's orbiting very, very, very far. And it has a lovely little moon. Whoops. I'm still selecting the planet. And what is this over here? Another moon. And what is this? A moon. Okay, so it has a lot of Selena moons, it looks like. Just bring up its graph here. Yeah, it's all Selenas. All warm Selenas. Well, this is a hot planet. Probably because it's a pretty strong greenhouse effect. And that's the Milky Way, isn't it? Milky Way? This is a random galaxy? No, this is a Magellanic Cloud. Wait a minute. So this is a randomly generated Wolf-Rayet star, though, right? Not the one that we actually know about in the Magellanic Clouds. Where's that star at? I lost track of it. Okay, let's bring up the ID again. There we go. So there's a Wolf-Rayet star. Okay, so yeah, this is not the one that we actually know about in the galaxy. This is just a randomly generated one in the Magellanic Clouds. Because somewhere in the large Magellanic Cloud that we're in right now, there is a specifically distinct bright spot, which is right here, I believe. And this contains a Wolf-Rayet star, which is probably this one, yes. So this is a Wolf-Rayet star that we actually do know about, very close to the one that you actually suggested. So, maybe thought that was kind of cool. There you go. Anyways, let's go ahead and move on to the next suggestion. Okay, so the next one is from Aaron Rain. Or is it Arena Rain? Sorry, I'm not good with names at all. Yeah, on the first, I wish you would give us temperature, proximity, and star type without more. It looks like a new. Yeah, the reason why I don't go too in depth with planet details and stuff is because I get so many suggestions, and I'm just really bent on time with these, because I try to keep them under an hour, but they always turn out to be like over an hour, at least more recently. And yeah, it's just kind of hard. I actually have like a two 2 suggestion limit for people now, and yeah. So let's go ahead and move on to the next one, which is from Jack Morgan 101. He wants me to visit a temperate desert with a nice view of the center of the galaxy. It also has a nice sunset. Let's go ahead and check it out. So yeah, mostly I just look at the visuals of planets. I don't go into far details with them, because if I did, I'd be spending 10 minutes per planet, and if I'm getting 20 planets or so, yeah, it's gonna take a while. So we have this yellow giant here, orbiting above this galaxy. Okay, sorry for the poor camera work here. Okay, there's the center of the galaxy. And it looks like we have a very, very, distinctive comet here. What is in here? There it is. What are you? A scorched desert. Is this the one you were talking about? Oh wow, that is definitely molten. No doubt about that. Okay, this is not the temperate desert you're talking about, but I'm kind of curious. Okay, so it's got that same effect that we had in that one desert, where you can see the light just kind of flying across where the planet is actually kind of blocking it out, and you can see the atmosphere is just glowing above here. There's the parenting star. But if I go and turn on the real planet brightness, oh, that is on. Okay, there we go. Now we can kind of see the effect a little bit better. I forget what this effect is called on Earth, but you can see it whenever you see right after a sunset. If you turn around away from the sunset, you can see that it's like kind of darker. That is the shadow of the own Earth actually being casted across the atmosphere. And yeah, that's what that dark region is at the horizon if you turn around away from a sunset. And that is essentially what's going on here, but with an extreme example of that. As the atmosphere here is very, very thick, and yeah, it's very, very, very hot, and there's a lot of light, so just turn that back on, and we can't even see. So yeah, this is like an extreme example of that happening. Like, okay, so there's your sunset, a little bit big, and you turn around, and that's the shadow of the planet, so that's kind of what's going on here. Anyways, let's go ahead and back out of this huge comet that just looks absolutely beautiful. And which one of these is the temperate desert? Huh. Let's check this again. Let's remove the A from here. There we go. Yeah, the A kind of threw it off. So this is a temperate desert. It has a relatively thin atmosphere, but it does have one that is certainly visible. There's no life here. I'm not going to bother reading out the specifications because he says check out the sunset. So here we go, towards the sunset. Very, very quickly. There we go. And where's that sun? I think I already skipped the sunset. Oh. No, there it is. There's the sunset. Okay, so this makes me think of a sunset that's kind of like in a northern region, where the sun just kind of rotates around the planet. Or like kind of rotates around your view and just bounces up and down, rather than actually go across the sky in kind of a more vertical thing. It's kind of on a horizontal plane when you're at like polar regions of the planet. It kind of looks like that. It looks a little bit more like that. And there's a nice star cluster, and there's the center of the galaxy, like you said. But you forgot to mention that we have a beautiful view of this ring over here. It's not like a kind of wide-angle version of the ring. If I actually fly over here, I should be able to see that, though. Yeah, now we have a really nice view of the ring, just being cast across the sky. And there's the sun there, but as you can see, we also have that huge comet tail kind of diffusing it, which looks very nice. So as we go off into our sunset, it looks very, very Earth-like, actually. Except for the huge comet tail on the ring, and the star cluster next to us in the center of that galaxy there. But yeah, very nice. Very cool planet. Okay, so we have another one from Jack Morgan 101, and let's go ahead and check it out. He says, it's another desert, but with life. And it doesn't look too good, but it has nice thin rings in a very close to a nebula. So let's go and check it out. Okay, so I saw the little red nebula, and actually, no, this desert actually looks really nice. It's actually really well detailed, which deserts are actually very good for. So we got some hills here. Oops, just smacked right into the planet, and let's check this out. Okay, so we got some sedimentary rocks, really jagged rocks as well. And there's our life, which looks like it just consists of the kind of simple grass texture. And, okay, very cool. I just want to check something real quick. Okay, I am recording in 1080p. I just wanted to make sure I wasn't recording this all in 4K. That would have been bad. So we got a nice... They're nice and dark, so not too visible. We have this volcano here, which is spewing out something. Yeah, something. We got a nice view of a star cluster there. That might have been the one we were just in. There's our parent star. Nice kind of white shine to it. Probably a white... Okay. We got another star there. That one's an orange dwarf. Okay, so what's this? White main sequence star. Okay. Select the world again, and from here, where the star is setting, we can actually see the other star just glimmering there in the back. Our star is set already. There's our rings. Oh, no wait, has it set? Yeah, okay, never mind. It hasn't set. We can see our rings, and as it kind of transitions to the night sky, we should be able to see this nebula just get brighter and brighter. And here is our lovely night sky with that huge nebula very close by. And there's the galaxy. If we come over here, we'd actually see the nice bright center of this galaxy, and we could probably see the nebula in the sky. Can we? Oh, it doesn't appear so. Trade-off. You get... Oh, no, wait, there it is. I guess it's not a trade-off. I was going to say it might just be a trade-off. You get to either see the nebula or you get to see the galaxy. And we have the lovely aurora effect here as well. The rings, though, not really bright enough in the night sky to see them. At least not from this angle. This did have rings, right? Oh yeah, it certainly does. So, yeah, very cool planet. And it has a... actually kind of far orbiting moon. Not what? What did I select? Apparently I selected a white giant binary system. So let's go ahead and move on to the next suggestion, which is from Andromeda. And here we go. A hot desert. We definitely have two stars shining on this. One blue, one white, it seems. Okay. Or just one red and very close. And one white or blue very far. Currently at a distance of 4.49 astronomical units. It is a white main sequence star. Okay. So we got Pac-Man here, as you can see. And let's just touch down right at the center point. Okay. So we have our white star over there, and our red star right there. And we have this kind of interesting shadow to the sky. Pan out a little bit so we can get a more... Okay, so we have multiple cloud layers. So we can get a nice, more distinct view of this. If we fly this direction, I assume, it should get darker, and we should see our true night sky. The sky, which has a lovely red, like, kind of shine to it. Very cool. Can't really see much in the sky because the atmosphere is a little bit thick here. And kind of a nice pink sunset over here. But over here we should have a completely different sunset. A much more Earth-like sunset over here. Very cool. And let's just touch down right here. Where we have like two different shines going on, as you can see. Get up in the atmosphere a little bit more. Get this off our screen, and let's hit play and just see what this does. The red star actually passed over the white star. this. So yeah, we got some really interesting colors going on here. Oh, we just hit a true night sky right there. I haven't seen that white star in a little while. I keep seeing that red star. Oh, there's a white star. So yeah, very, very cool effect when you actually have multiple stars orbiting around like this. Or not orbiting around, but you know, the planet's rotating. So yeah, you get a lot of cool colors. Yeah, let's go ahead and pause the game, turn back on the normal camera. And yeah, really nice find, Andromeda. Andromeda, really cool planet. Let's go ahead and move on to the next one, which is same galaxy. Get rid of that question mark. And here we go. Hot desert. Okay, so we have kind of a Venus-like desert here, kind of a thick atmosphere. Not quite as thick as Venus, I don't believe, but let's go ahead and touch down and see what these cloud layers look like, because I'm sure they're going to be kind of detailed. No, they're actually not. In fact, the atmosphere doesn't even appear all that thick from the surface. So, 33 atmospheres of pressure once we actually touch down on this planet. Got a temperature of 158 degrees plus a greenhouse effect of 173 degrees on top of that. A diameter of 14,000 kilometers. And what is so interesting about this? We got a lovely ring and a nice high altitude aurora effect, and not very tall. There's the center of a galaxy. A distant galaxy. A cataloged galaxy. Okay. Is there anything on the other side? It's very, very far off from this galaxy. We have a couple of moons orbiting around. There's the shadows from our rings here. Where did that galaxy go? Oh, okay. We have something going on here behind our rings. We have what is a red dwarf? Can't even tell that's red. Let's just take a moment to soak this in. This is a star receiving so much light from this star that it has a shadow. This star has a shadow because that star is so bright. Right here we have a blue main sequence star. Okay. So I just wanted to point that out, that this star has a shadow. I mean, it's a very bright shadow, but it's a shadow. Insane. And then over here we have this giant red giant here, which is essentially that if it was a red main sequence star or something, a yellow main sequence star. And now it's a red giant. So this is like a star that is kind of going through its giant phase, and this is basically what our sun will be eventually. Whoops, did not mean to do that. And yeah, eventually it'll go nova and lose its outer shell and just be a little white dwarf. Yeah, it's just very cool. I wanted to point that out. And I think this one even has kind of the same effect going on. Check that out. See how it's brighter right here than it is over here? So it's even doing it to the red giant. So this is a really, really, really bright main sequence star. So, very cool. And let's just hit play because I like the, wow, look at that. Because it's orbiting around. Check that out. It's just like blinking. I like the energy and all that just kind of flowing off of the stars. It's really cool. And ah, there it is. Yeah, you'd think it'd be kind of difficult to lose a galaxy, but I managed to do it. And I assume this is just a beautiful spiral galaxy, and it certainly is. So let's go ahead and move on to the next one. And this guy's saying, come on, explore Earth. Well, that planet sucks. Alright, here we go. Forms on this planet are kind of jerks. So, let's check out Earth. Let's go ahead and go to, Yeah, let's go to, where's Brazil? Isn't Brazil like in this region, or is it up there? I forget. I don't even know where Brazil's at. Okay, so I've touched down, and look at how beautiful Earth is. We have some rather low resolution clouds, which, yes, I know I could download a higher res texture pack for this. And we have some poorly generated oceans, which, as you can see there, kind of messes up with this terrain. We have a nice low res texture of South America. And, yeah, there's not much to explore here. Even if I got the high-res texture pack, it doesn't really get much detail. There's no actual, like, bumps on this planet, really, at all. Because, yeah, it's kind of the same for all of our planets in our system. They're just textured. They're not actually generated, really. It's just a ball with the texture on it, pretty much. If I hit F2 here, we have Saturn. I think it's even actually a gas giant in the game. If I actually touch down on it, I don't think I can actually go inside of it. No, it's actually a terrestrial world in the game. You can even see it has like a sand texture going on. Going on with Saturn. I think I still have real planet brightness on. There we go, that's the Saturn we know. We got Jupiter over here. Same deal. I think I could just smack right into it. Not actually a gas giant. Just a textured ball. We got Venus. Venus, I do believe we could actually go into the atmosphere of, though. We certainly can. But again, just kind of a textured ball. Mercury, I think, actually does generate terrain, but I could be wrong. The Selenas in our little solar system do, I believe, generate actual bump mapping. Yeah, but it's kind of low resolution. It doesn't actually get, like, higher detailed as you get closer. I'm sure if I got the high-res texture pack, this would probably generate a lot better. There's a Haumea. Little potato asteroid. Let's just touch down on it. This one actually generated a little bit. And for the last one, Neptune. Texture ball. Sand texture. Yep. Okay, so let's go and move on to the next suggestion. I hope you enjoyed that exploration of Earth. If you want to actually check out a cool video that I did on Earth, check out my 2017 solar eclipse. That one's actually a really cool effect. It's one of the few things that you can actually do on Earth in this game. So, let's see. Another suggestion from This Is Not Interesting, but this time it's IDs. So let's go ahead and check it out. He says, list of dual planets. He has 3 suggestions, so I'm just going to kind of glance over them and just check out the effects of the dual planets rather than actually reading off the details of it. So, right here, the details are on the left if you actually want to find out. It's actually 2 Selenas orbiting each other, which is actually pretty uncommon. Is this actually a dual planet, though? The mass of this one is significantly lower. That might just be a moon. That might not be a dual planet. Yeah, that's actually a moon, not a dual planetary system. The next one is HIP 91339-5. And this one's actually cataloged, so let's check it out. I wonder how you discover if something is a dual planetary system. Okay. Now this is a dual planetary system, but what's cool about it is it's a dual gas giant, which always look cool, and I think we probably have some ice worlds orbiting around here. Cold Selenas. Might as well be ice worlds. And yeah, let's just watch them rotate. Jupiter actually has the same kind of influence on our star, the Sun, by the way. The Sun actually does rotate a little bit because of Jupiter's gravity. It doesn't just sit in one spot or fly through the Milky Way. It actually does wobble a little bit because of Jupiter. That's actually one of the kind of ways that we could actually discover exoplanets is basically their effect on their parent star, not just the not just blocking the light, but how much it makes the star itself wobble a little bit. So yeah, very cool. Let's go ahead and touch down on the next one real quick. And here we go. Okay, this one appears to be dual planetary. Yeah, it certainly is. And it's another two gas giants actually orbiting around each other. And if you watch for a brief second there, you can see it eclipse the other gas giant. Very nice. And there's their orbit around the parent star. So I don't think there's a way I could actually touch down on these. I think I can get close enough to where it makes me rotate around with it, or I could just right click it and or not. Oh well. And as you can see there, you can see it get a nice shadow and kind of glow around the star there. Oh, there it is. You get a nice glow around the gas giant, so very cool. Okay, so the next suggestion is from Dylan Bush, and that is the last suggestion for this video. Let's go ahead and check it out, and I may have skipped a few suggestions. This is not interesting. I don't know if you've been like listening to my previous videos, but yeah, I'm doing 2 suggestions per video now, so sorry if I've skipped over a few years. Just resuggest them in this video and I will get around to them. Or like in the next video, I mean. Yeah, this video. And I'll get around to them in the next video, that's what I meant to say. And what galaxy is this? It's not IC1101. No, it's just a random galaxy. IC1101 does not really have like this define of stars. And oh, that's a pretty view of that spiral galaxy there. So let's go ahead and turn off our orbit map real quick. I just want to take a moment to note how beautiful these rings are. Even though they're not colorful. Actually, they kind of are. I really love when they generate this way. Like this nice, like it has multiple separate bands. Which tells me that the mass of this planet's actually kind of a lot for what it is. But, yeah, it's just really cool. Actually, no, it's actually pretty low mass. Well then. Never mind, it's 88% of that for Earth, but the diameter is actually bigger. So it's actually a lower mass planet than Earth. But, yeah, it just means things got caught in its Roche limit, like, very, very close. In 2 different sections. Like, there was a moon orbiting here. There was a moon orbiting here. They exploded, and this is probably remnants of the moon, which are these adorable little asteroids. They're kind of consuming their own little section of the ring. And will probably either be pulled in or pushed out by the planet's gravity eventually. So let's go ahead and touch down here, and it looks like we have some nicely generated rivers. Kind of like a nice little chain of them. Ooh, okay, so we have some nice shadows here. Okay, so it looks like we have a treetop texture here, which you can see like the dirt on the ground, you can see like the trees. Satellite image of some trees here. And we got some winded sand on the beach. And I think that's just the simple grass texture. So really nice. Pretty large, pretty wide rivers actually. Got these lovely shadows from our ring system over there. You can see from the atmosphere the star just shining across the rings, or shining through the rings rather. Let's go ahead and check out over here where there's a few hills. Better get out of these ring shadows. Okay, so we got some kind of nicely eroded, rounded hills. You can see some grass or trees or something growing on the top of these. So really cool rocks, and they have a nice sedimentary texture. There's even more of the grass texture, this time a little bit more defined since we're out of the shadow now. Yeah, this is just very, very beautiful. Very Earth-like as well. The ESI is 93%, so actually very, very Earth-like. The atmosphere is carbon dioxide and oxygen. Atmospheric pressure of 4.85, so it's actually a very thick atmosphere for such a low-mass planet. So yeah, I think on this note, if you guys want to visit this planet, the ID is up in the top left, and it's a very beautiful planet, and I imagine the sunset is very, very Earth-like. So, let's go ahead and touch down right here under this aurora. So, if you guys like the video, please leave it a like. If you want to see more videos like this, please do subscribe. It really does help. And I will see you guys in the next one.